My name is Neil Elliott. I'm Senior Director or Director Emeritus here at ACEEE and one of your co-chairs. We're still figuring the platform out, so apologies for the little challenges we are having here. And please let us know if you have problems in the future. Together with my colleague Prakash Rao from Lawrence Berkeley National Labs as co-chairs, we've spent a year planning the conference and appreciate all the contributions from all the speakers. Want to recognize in particular the work of the panel leaders. The real heavy lift that comes from this conference is our panel leaders who have been responsible for organizing the technical sessions, which will begin today at 1:15 East Coast time. Look forward to you joining us. Hope you were able to join us yesterday for the opening plenary with Kelly Speaks Bachman. That was really great. Also want to take the opportunity to acknowledge the conference staff here at ACEEE, because the conference staff at ACEEE really are responsible for making this conference happen. And that's a really exciting opportunity for us to be able to work with such a talented professional staff. Also want to thank our sponsors who we would not be able to do this conference without them. We had the opportunity to hear from Don with DTE yesterday, and one of his colleagues will be joining us here on this panel on renewable energy. Want to also remind people, please fill out the evaluations. Join us for the panel debrief at 5:15 this afternoon with the panel leaders and have a chance to do some networking there. And at that point, with that, I want to turn this over to Dr. Diana Bauer, who is the acting Deputy Director of the Advanced Manufacturing Office at DOE, who will be moderating this panel on renewable energy. Diana has been with DOE for a number of years. Prior to coming to the Advanced Manufacturing Office, was at the Office of Energy Systems Integration and Analysis at DOE, working on a number of issues connecting energy with other systems, and worked in particular on the energy water nexus, a topic near and dear to my heart. Before joining DOE, she led the extramural sustainability research program at the Environmental Protection Agency, and is a PhD mechanical engineer from University of California, Berkeley, which I learned last week should be referred to as Cal. And we're really excited to have Diana and this distinguished panel talking about the important issue of renewable energy in corporate sustainability. And with that, thank you very much.
Thanks, Neil. Hi, everyone. Good morning. Thanks for joining the Renewables Plenary. I have a few housekeeping items to review before we get started. First, I'll add my thanks to Neil's to the sponsors, particularly DTE. Please click on the sponsor link on the left-hand column of your page to visit their sites and learn more about them. Today, we have an exciting lineup of speakers. After all presentations are given, join us for the last 15 minutes of the session as the speakers answer a few questions from the chat, and you're the ones putting the questions in the chat. ACEEE will collect any remaining unanswered questions and send them to the speakers to respond to after the conference. So with that in mind, please use the chat box only to ask questions for the speakers and refrain from engaging in dialogue with other attendees. If you would like to connect with the other attendees, please take advantage of the attendee link, also found on the left-hand column of your page. Any attendee who has created a profile can be found here. In this column, you will find attendee resources as well. The resources contain the conference proceedings, attendee list, and an evaluation survey to complete at the end of the conference. Anyone who fills out and includes their name and testimonial will get a discount to attend the 2023 summer study. In the program participants link, you'll find information about all the presenters, including bios and copies of their presentations. Last, join us at the end of the day for post-panel debriefs to learn about other discussions that you may have missed. Remember, all sessions will be recorded and available on demand after the conference. Now let's get started. The first speaker is David Harwood. David Harwood is the Director of Renewable Energy for DTE Electric, the largest subsidiary of DTE Energy. He's currently responsible for renewable energy strategy, project development, vendor agreements, regulatory compliance, purchase power contracts, and renewable energy operations. David has been with DTE since 1982. That's a long time. And so he's had many roles at DTE. He held lead positions responsible for integrated resource planning, merchant power operations, generation and environmental strategy, wholesale power supply, and reliability planning, and the list goes on and on. He has a BS in chemical engineering from the University of Michigan and an MBA from Baker College. David?
Hello, everybody, and thanks, Diana. Just to further that introduction before I go into a few slides here with respect to DTE and renewable energy, which may help form questions or dialogue later. We are Michigan's largest investor and producer of renewable energy, and since 2009 have driven about $3 billion of investment in renewable energy infrastructure. And we're about ready to hit a kind of an upswing in our development and have about $2 billion of investment planned over the next 3-4 years. We currently have about 2 gigawatts of renewable energy online, just short of 2 gigawatts. And what I'd like to describe really quickly here is the drivers behind this strategy and this growth and transition for DTE from fossil to renewables that started about 10 years ago. So if I can quickly advance my slides, there we go. As you can see here, this is our publicly stated goal anyway, as what we're driving to. We've updated this numerous times over the past few years, accelerating our targets and the timing for those targets each time we do. I don't think we're done accelerating that. I would expect even by the end of 2021, a new, more aggressive timeline for us to announce. But right now, we have an expressed goal of 80% carbon reduction by 2040 and carbon neutrality by 2050. As you can see, we're making good progress toward that goal. But like I said, we're going to be accelerating our targets and our pace and probably announcing something by the end of this year. Moving on, what I'd like to really quickly do here is describe 3 really key drivers to this transition and this growth around renewables, at least what's driving us. The first one was Michigan's Renewable Portfolio Standard, which initially passed back in 2009, requiring all utilities to be at 10% of retail sales by 2015. That was later revised to 12.5% by 2019 and 15% by 2021. DTE and our companion utilities in Michigan all met those targets and will meet the 15% goal by the end of this year. The next big key driver is something that's probably pretty familiar with all of you, and that's cost. Obviously, the cost of wind and solar generation in the United States has dropped significantly over the last 10 years, and it's now pretty much on par with traditional forms of generation. And while tax credits and other subsidies were key to initial development growth, it's becoming less and less of a need. We are building wind and solar projects in Michigan this year right now for somewhere in the 4.5 to 5 cent range life cycle costs. They would be higher without tax credits, but we see these costs continuing to drop as we go into the future. Our growth, at least in Michigan, has been predominantly wind, as that's been the most economic form of renewable energy to date. But we are seeing a shift, and I would expect that the majority of our generation, our capacity additions going forward, are going to be solar. And then finally, the third really and most important one is customer demand. We began developing a voluntary renewable program for our customers way back in 2015 timeframe, launched the first one in 2017, all under the brand name of My Green Power, MI Green Power. The first program was launched in 2017, predominantly targeting residential and small commercial customers. We now have over 33,000 customers on that program. And then in 2019, launched a similar but slightly different version of the program for our large industrial customers. And that has received huge interest and subscription. And in just a few short years now, we as far as we can tell through our benchmarking, we now are one of the top 3 voluntary programs on a megawatt hour basis in the country. And you can see some of the names of the customer partners that have subscribed in large ways to this program. Just to highlight this, we just recently, this past spring, put 450 megawatts of new wind parks online. And the date they went into commercial operation, 90% of the output was already fully subscribed to some of these customers. And so our challenge right now is keeping up with that demand, and that which is all incremental to the RPS and other build that we had going on previously. And this is really what's driving our growth right now. We are continuing to add different versions of this My Green Power program. You'll see us adding voluntary offerings for municipalities, low-income customer segments, and other areas that we may target for particular customer interest. And then finally, just to kind of recap, kind of a look from a map perspective at our portfolio. We've got 18 wind projects and 32 solar projects in operation today, all in Michigan. Like I said, just short of 2 gigawatts earlier. And by the end of 2023, probably enough, we forecast at least enough renewable generation to online to equivalent to the use of about 1 million Michigan homes. So I'll stop there and hand it back.
Thank you. Our next speaker is Edward Stones. Just one thing I want to let folks know is be sure to be writing your questions in the chat. I noticed that we don't really have questions in the chat yet. Maybe they're starting to come in now. Edward Stones is Global Business Director for Energy and Climate Change at Dow. He's responsible for delivering energy business profitability and power production at the 14 company-operated power facilities. And he leads Dow's energy conservation and greenhouse gas reduction efforts, and actively participates in the company's advocacy for energy sustainability and climate change. He joined Union Carbide Corporation in 1997, and Union Carbide is now a subsidiary of Dow. He's had a number of roles along the way, and in 2012, he was appointed Director for Global Hydrocarbons Business Development and Hydrocarbons Risk Management, and in 2014, he was appointed Senior Director for Investor relations. He's delivered a lot of presentations throughout the world, and he served as the chair of industrial efficiency for the subcommittee in the writing of the National Petroleum Council Hard Truths Report, and has provided testimony for Senate on the role of natural gas in climate change. He holds a bachelor's degree in chemical engineering and a master's degree in environmental engineering from Stanford University. Edward?
All right. So thank you for the introduction. Let's just get right to it. So basically, part of the issue for Dow is that we have to lead this at scale. We have set aggressive carbon reduction and neutrality goals, and we're today the leading purchaser of clean energy in the chemical industry. We're also among top 20 among global corporations in terms of clean energy use. In 2021, about 26% of our purchased power and electricity came from clean sources, and that includes wind, solar, biomass, landfill gas, and hydro. We're very keen supporters of additionality. It is challenging for our industry at scale, and you can see there's some statistics on the bottom of the page where we have, globally we consume more than 7 gigawatts of power and steam and about 1 million barrels a day of feedstocks. We have 50 gas and steam turbines and boilers and more than 100 furnaces, and we serve 30 major sites and for 3 very significant market segments. These are more than $100 billion each in terms of total market scale, including packaging and specialty plastics, infrastructure and intermediates, and performance materials and coatings. Our products are critical to the world reducing its carbon intensity. And so this next slide shows that for more than 3 decades, sustainability has been an imperative to our business. And last year, we announced the new breakthrough targets of 5 million tons of reduction by 2030 and carbon neutral by 2050 that I showed on the prior slide. We see these targets as a catalyst for growth and innovation. And over the past 15 years, we've reduced our carbon emissions by about 15% while growing our business. And we see a viable pathway to reduce an additional 15% by 2030. And that's going to come through further, if you look at the lower right chart here, we've got a kind of graphic of how that happens. That continues through efficiency and optimization. And then we also add on top of that renewables and clean power in kind of the yellow. And finally, implementing new emission management technologies such as low carbon hydrogen and carbon capture and storage. We're working with utilities and regulators to supply clean purchase power to the majority of our Dow sites by 2030, and we're making good progress on that. Last year, we increased our agreements to purchase cost-competitive renewable energy in Kentucky, Texas, Brazil, and Spain, and we're working on other things throughout the world even as we speak. And we're preparing for the full transition of our Terneuzen operations in Holland. We're also working to optimize the energy efficiency of our sites by lowering our and developing breakthrough technologies such as electric ethylene steam crackers, carbon capture and sequestration, and potentially using blue hydrogen, where we could be among the first in the industry to do so by 2030. From our customer base, we see widespread support for decarbonizing emissions and that demand across the value chain, and Dow's well placed to lead and continue to benefit from this evolution. Many of our products lower our customers' emissions more than the carbon emissions used to produce them. And that does things like enable lighter, safer, and more fuel-efficient automobiles, more energy-efficient buildings, and food that stays fresh and safe longer. And all this is critical for a world that's going to add 2 billion people by 2050. This next slide really kind of sets out what we see as the kind of requirements to achieve this across the energy ecosystem, if you will. We see across the policy space, you do need global engagement. We're very happy to have seen the United States rejoin the Paris Accord. We need to pursue a market-based, economy-wide price on carbon, and we'd see that preferably as an emissions trading system. And then the revenue that's captured from that pricing needs to direct that revenue into low carbon process technology and breakthroughs in that space, infrastructure for things like CO2 and hydrogen, as well as to catalyze demand pull, including next generation nuclear and carbon capture, use, and storage. We need to ensure reasonable timeframes for the transition, and we need to avoid significant economic impacts to both manufacturers and taxpayers. And I'll remind everybody that manufacturing relies on reliable power, process heat, and natural gas-based feedstocks. That low-cost energy and petroleum-based raw material supply has provided a significant cost and competitive advantage for the U.S. industry. As we take actions to improve the climate, that will impact the cost of energy, and the policy choices we make on this path to net zero will either increase or decrease the national manufacturing competitiveness. So it's critical to get this policy right as we move forward. And then finally, I want to bring the forefront the perspective of a large manufacturer who relies on stable power grid to run a wide range of equipment, including bringing large motors online safely. So things like intermittency, spinning reserves, inertia, fuel supply lines, and demand response mean a lot to us. In these ways, conventional power technologies are quite different than the renewables. So as one example of this, the chart on the left shows the capacities and actual deliveries of our wind PPAs in Texas as compared to one of our gas turbines. Although that doesn't look too different, the actual delivery of power on a 15-minute basis, I'm going to show you some data from July of 2017, is quite different. So that the wind PPAs are the dark blue and the light gray, the gas turbine is the light blue. Figure out which one of these two is easier to plan for and manage if you're a manufacturer. I don't believe that the grid can operate with 100% renewables today. In fact, we believe it's more like you need 3 dispatchable megawatts for every intermittent one that you deliver. And over time, technologies like batteries and grid forming can help with this, but there are real limits on the cost, capacity of rate, and the rate of discharge in the real world today. And then even batteries won't help you overcome the seasonality in production, which is shown in our panhandle wind on the left there. And you can see it delivered more wind in March when prices are low and demand is low than it did in July when prices are high and demand is high. In Germany, the Netherlands, the US, and Australia, these clean energy targets have had significant unintended consequences, resulting in wide day and night swings in power pricing and highly unattractive investment environments for conventional power producers. Over time, and as gas and coal generation are retired, renewable heavy grids will experience further supply and demand swings, potentially brownouts and blackouts, and this can be serious for residents, as we've seen recently, and it can be prohibitive for manufacturers when considering where to locate new investments. But I want to temper this a little bit. As the leading consumer of renewable energy in our industry, we believe that renewables are an essential tool in the decarbonization arsenal. But like any tool, they need to be applied judiciously, and the technologies need to evolve to support the needs of users who depend on a stable and reliable grid. So let me pass that back now.
Thank you, Edward. Next up, we have Colin McMillan, who is a senior analyst at the Washington, D.C. office of NREL's Strategic Energy Analysis Center. His research aims to quantify and understand energy and material use in economies. His primary focus is improving data and methods used for modeling the industrial sector, particularly within energy systems models. Dr. McMillan's most recent research has involved detailing industrial process heat demand at greater spatial, temporal, and operational resolutions, and evaluating the potential for alternative heat technologies, including solar thermal and PV connected electro technologies. Colin?
All right. Thanks, Diana. I really appreciate the opportunity to be part of this panel. Today I wanted to give a really brief overview and summary of a technical report that we published at NREL at the beginning of this year on opportunities for solar industrial process heat in the United States. Just to get everyone baselined and on the same page, when I mention industrial process heat, I'm talking about the transfer of heat to a material within a production process by convection, conduction, or radiation. And the potential to use solar technologies, solar thermal, as well as photovoltaic connected electro technologies for meeting this industrial process heat demand in the US is an understudied and important topic. So this little figure on the right shows existing solar process heat installations in the US as of 2019. There aren't many. Data are a little old, and I think there are at least a couple of new projects underway in California. But anyways, there's not much going on in this field right now. That doesn't mean that there aren't some big opportunities here. So the project team was really motivated by two fundamental questions. So the first was, what are the geographic, temporal, and operational characteristics of industrial process heat demand in the US? And then what are the county by county opportunities to meet that demand with different solar technologies? So I might be a bit biased, but from my standpoint, it seems like this industrial process heat topic has gotten an increasing amount of interest in the last couple of years, and really for good reason. So IPH is a major use of energy in the United States. Of course, industry as a whole is the second largest end user of energy behind the transportation sector, and IPH demand by itself is the majority of fuel energy used by industry, equivalent to about 40% of transportation and about 28% of residential and commercial buildings combined. And nearly all of IPH energy is provided by fuel combustion, and most of that is fossil fuels. And so I will say that I think by and large, a lot of the recent focus on industrial process heat has tended to be on these high temperature processes like steelmaking and cement kilns, and rightfully so. Those are difficult to decarbonize. But when you actually plot out sort of the cumulative energy demand for industrial process heat in the US, you see about 2/3 is actually for process temperatures at or below about 300 degrees Celsius or 572 degrees Fahrenheit. And it just so happens that those temperature requirements are well matched to what can be provided by existing solar thermal and electric technologies. And of course, temperature is only one part of the equation. So I want to direct everyone's attention to these three charts at the top of this slide. In the middle is our estimated county level industrial process heat demand in the US for 2014. Compare that to the two solar resources maps that are on either side. You can see that there's not necessarily a great overlap between where the best solar resources are and where the most intensive process heat demands are. And so those process heat demands tend to be located on the Gulf Coast, on Texas and Louisiana, as well as around Chicago for steelmaking and such. But that doesn't necessarily mean that there aren't opportunities to explore. And I should also say, since we have maps up, that we found that at least on a county level, there is typically enough available land for these solar technologies to be built and to meet industrial process heat demand for those counties. All right, so to talk very briefly again about the technologies that we were interested in. So we evaluated 7 different solar technology packages. 3 of those are solar thermal technologies, flat plate collector with water storage, parabolic trough collector with and without 6-hour energy thermal energy storage, a linear Fresnel direct steam generation system. And then we also looked at 4 different PV connected electro technologies. One, an ambient heat pump with water storage, an electric boiler, a resistance heater, and waste heat recovery heat pumps or high temperature heat pumps. All right, I wanted to present 2 results slides for everyone and also to point people to the technical report. There's a link at the end of the presentation with a lot more information, a lot more detail. But just to, I think, slice the opportunities in terms of different general industry areas as well as the technologies. Those concentrating thermal collectors have the most opportunities in the industries that have a lot of medium temperature steam needs. So we're talking pulp and paper, chemicals, and food. From the PV and electro technology perspective, I wanted to highlight the opportunities we identified for resistance heating in metals. I will also say that there's about the same size and magnitude of opportunities for technologies like electric boilers in the food and chemicals industries as well. Of course, the time and geographic dimensions are also important in terms of quantifying opportunities. And so these 2 figures here show the percent of the year where different solar technologies meet the industrial process heat demand for different counties. So the figure on the left shows the case of PV and electric boilers. You can see that opportunities are, I think, relatively widespread throughout the country. Compare that to the results for the parabolic trough collector with storage. You see those opportunities generally follow the lines and the demarcations of where those best solar resources are. But I think this, in general, shows that there is not necessarily a one-size-fits-all application here, and it's really, really we get down to what's happening at the facility level, what's happening with individual processes, and we did not get down to that level of detail in this analysis, but we certainly point to the direction and the need of that type of analysis. So just to start wrapping things up quickly, this analysis was the first national analysis completed for the United States conducted at the county level. We found that solar thermal and these PV heat technologies can meet many temperature needs, about a quarter of all estimated industrial process heat demand in 2014. Many of the counties have sufficient available land, although site-specific details do matter. So on average, about 5% of land in a given county is needed for these build-outs of these solar collectors and solar arrays. However, we really need to get down to a site level assessment of individual facilities, especially if we're talking about economics. And I don't know if you've noticed, but this is the first time I've mentioned economics in this presentation. It's something that we didn't cover in this analysis, but was something that was addressed in a related analysis. So boiling things down into 3 key insights. All contiguous U.S. states can readily benefit from solar heat technologies and meet a large portion of their IPH demand. It's possible for these heating technologies to reduce CO2 emissions by about 15%. And thermal energy storage is really a key to the success of these technologies. And this is another significant area that I've essentially glossed over in this presentation, but really thermal energy storage and other types of storage are key for these types of technologies. So this was just the start of this type of analysis and research, and there's certainly more that can be done. We identified 4 different areas to focus on. Really, I think 3 of these have to do with getting down to site-specific details, site-specific modeling about how to actually integrate and quantify, characterize these technologies, specifically how to get them into processes and how to enable different facilities to evaluate these types of systems for their use, as well as, again, this focus on energy storage, both in terms of thermal batteries as well as electric batteries. So those are key future research needs in this space. And I will just end with a thank you, and just to highlight links that are available for folks who want to go and check out the report and other resources as well. And that's it for me.
Thanks, everybody. Now we're moving on to Q&A. And I think all of the panelists are going to be on the screen here. Here we go. So I've been going through the questions. There's some good ones in the chat, and tried to, slice and dice and mix them up a little bit so that we can have a good discussion here. My first question is, broadly, what motivates companies to pursue renewables? And then, sort of as a second part to this, there's sort of different configurations. There could be renewable offsets. There could be renewables on site where they don't actually, where it may reduce their, electricity demands from a company like DTE. Or it could be that maybe they're renting out their, land for a solar farm. So with those different possible configurations, what motivates a company? And then also, how should this, how will this, how should it, would it be good? What would be a delightful new relationship model for industry and utilities in thinking about these issues? Does anyone want to take this first?
Yeah, I'll go first. While I explain what drives us and what's driving us, it's customer demand. But these are the companies I think you're talking about, Diane.
Yeah. So what motivates them to demand from you?
Right.
Yeah.
What do we see from our customers as far as what's driving them? And it's a number of reasons. Some companies, understand and have a social environmental responsibility, and believe that they have that responsibility to reduce carbon. And so they look for the most effective way to do that. Some like to, as you mentioned, install renewable projects on their property. But typically, unless you've got a lot of land, especially big industrial customers, you're not going to have enough land to build a project that completely offsets your carbon emissions or your carbon footprint, even the electricity carbon footprint. So they look to the utility to kind of do that for them, and that's where our My Green Power program comes in, because the assets that we sell them or subscribe them to are not located on their property traditionally. We have some customers where we've done behind the meter projects for, but the most part, you can think about our My Green Power program as kind of a large community solar program, with the community being defined as our service territory, and customers signing up for the output of that. And I think ultimately, though, at the end of the day, that these large businesses that are interested in reducing their footprint are doing so because they believe their customers want them to do it. So I think at the end of the day, it all drives down to, what does the end use customer want, right? If Ford is now going to be building F-150s, pickup trucks that are electric, they also have an interest in wanting to build those F-150s with 100% renewable energy. That's just one example, right? And then they can market that to their customers, that not only are they getting an electric vehicle, but they're getting an electric vehicle that was built in a sustainable way. So we kind of hear stories across the map on why people want to do that.
Maybe I can go next. I would say, from my perspective, certainly the pull from our customers for more sustainable solutions is important. But to be frank, economics matter as well. And, I think depending on the geography, renewable be, if you can manage the volatility, and that's a big if, renewables can be the most economic source of power, particularly, I would say, in the U.S. in deregulated markets and in places like Latin America, where you can get very good hydro situations and also very significant solar and sometimes wind. So, for the most part, it's at the end, everything breaks down to economics. We do have sustainability goals, but those sustainability goals are set in the service of customer demand. So that's what I would say.
Do you have anything to add, Colin?
No, not on that one.
Okay. Okay. So maybe I'll ask a question that you can help answer. So we've heard about a number of kind of technologies, industrial decarbonization technologies. Edward, you talked about hydrogen, and certainly Colin, you talked about using solar for industrial heating. We also have a number of questions in the chat about other potential technologies such as heat pump, CHP, CCS, and I'm just wondering if you two have some kind of wisdom on how those different technologies will work together, or which ones you want to focus on, Edward, and Colin, how you see the solar thermal working with other technologies for industrial decarbonization.
So maybe I'll start. I think one of the things that is incredibly important for manufacturers is reliability, and so I see a world where cogeneration goes away. And we're also very big users of steam. To decouple traditional cogen, you're probably going to want to do that with hydrogen. And from an economics perspective, you're going to start with probably blue hydrogen, which basically means you're going to take the carbon out of the methane before you put it into the cogen as hydrogen. But that has significant cost implications that need to be managed and understood. You can't get clean hydrogen for anywhere close to the cost of natural gas today, and so the country needs to figure that out from a policy perspective. So we'd certainly see hydrogen as an important part of it. We absolutely believe all sorts of efficiency are important, including things like, as you mentioned, heat pumps and other technologies in that regard. Certain for long-term reliability and stability of the grids, we think things like grid forming technologies and batteries are going to be important. I can't see any economically viable technology not being used. This is always the case in energy. You need everything you can to make it as reliable. You need it reliable, cost effective, sustainable, politically viable, and within the realm of physics, right? All five of those are important to make this work.
So can I ask a follow-on question? How frequently do you at Dow kind of evaluate the landscape in terms of what's cost effective, et cetera? Like how do you work with that? Because these things are changing over time, and
yeah. So look, we produce 7 gigawatts of power and steam, and so that's across. We have 14 sites where we have cogeneration equipment. We have 100 plus sites. So, generally speaking, I would say, all the time. It's not a when do you do it. It's a when are you not doing it question. And
right.
We have a technology center to support us in that, and we also routinely, go out. We I think last year we had 4 separate or 5 separate renewal contracts we did. So it's frankly, each opportunity we're looking. We have a commercial team and a manufacturing team and a technology team looking at all the time.
Okay. Colin, did you have something to add on how you envision the solar thermal heat working with other decarbonization technologies?
Yeah, I mean, I think there's naturally the interaction and relationship with energy efficiency. So, I mean, just doing all sorts of efficiency measures to, say, reduce your steam demand, do some heat recovery in order to effectively size your solar field and the production of your solar thermal system. That's a big deal. I think sort of getting to this everything, all technologies point. I think it's also worth considering what's applicable to different sizes of manufacturers. So, I mean, maybe a mom and pop shop that's running a boiler 9 to 5, 5 days a week, they have a very different need. Maybe they have a heat pump. Maybe it makes sense for a solar thermal system for them, versus a continuously operating chemical plant. So there's all sorts of things that will that will need to be addressed, and certainly there's different layers of complexities and difficulties with all of them. But yeah.
Okay. We have a number. One of you brought up batteries, and we have some questions on batteries and long duration storage as well. So maybe first part of the question is, what role do you see batteries and related storage technologies playing in, I guess, helping to smooth out the electricity variability under a renewable portfolio, or other things as well? I mean, where do you see batteries as being useful? And then there were some other questions or discussion about the long duration storage. So what would be a magical technology that would really help with some of the longer duration needs for something like storage?
Yeah, maybe I can start with that one.
Let's go ahead.
I would say, the problem we're trying to solve, right, is to like the question indicated, kind of flatten this out, right? So you can go at it a couple of different ways, right? Either trying to figure out how to mitigate the volatility or the intermittency of the generation supply, and trying to figure out how to flatten the demand side, right? And so you can kind of get at it both ways, and probably should get at it both ways. So yeah, battery storage is certainly something the utilities are looking at, and in different parts of the country, I would say the problem is a little bit sooner than maybe later. In Michigan, we have the benefit of a very large pump storage facility that allows us to balance generation a little bit. And we also don't quite have the renewable penetration yet, where we're, actually seeing in real time some supply side problems because of intermittency, but it's coming. And so we're looking at battery storage, we're looking at hydrogen, a number of different technologies that might help us kind of smooth out the supply side. And then we have a very aggressive and comprehensive energy efficiency program for our customers that helps smooth out the demand side.
So I'll give a controversial and different answer. I mean, I don't think batteries work at the scale we need today. Okay, and my evidence for that is that in Texas, we've seen $9,000 prices followed within 24 hours by negative prices. Okay, and so I think it just, there's not the scale, there's not the speed of response, and there's not the appetite for the cost that would be required to deploy significant enough battery resources to offset the volatility that is actually real. You know, in the highest times, our assets deliver 2 or 3% of the renewables that they deliver in the lowest price times, and that's something that needs to be addressed and worked on. I do think longer term, batteries are going to be part of the solution, but let's not kid ourselves. That's 5 to 10 to 15 years from now. That's not now. And I also think hydrogen could eventually be a storage solution. But anybody who's talking about hydrogen is talking about, even gray hydrogen is $1 a kilogram, which is $10 a million BTU, or 3 times the price of natural gas today. So these have significant cost increases, and frankly, those costs are not uniformly borne by the grid today. They're usually forced on the people who have the lowest, the most need for reliability to deal with, and that's usually industrials. So I think there's some real long-term issues that we need to work on there, including things like grid forming technologies, which allow you to deal with what in effect are DC technologies in a lot of cases that need to be managed properly. The nice thing about a cogenerator or a traditional power plant is it's got a huge amount of inertia, and that protects your grid. So there's a lot of technical details in there, and I'm not a highly technical guy, but I think we're quite a long way away from that problem being managed.
Let me jump back in. I agree with that. I don't think, Edward, your statement is controversial or out there at all. I think I would represent that battery storage and some of the hydrogen and some of these others are going to be a part of the storage solution in the future, but there's a lot of work left to do. There's no doubt about that.
Yeah.
That's why they pay us all the big bucks, right?
Well, yeah, the opportunity is to find the way to manage the volatility, and provide the benefits which you see, which is potentially lower variable cost and lower emissions. But it's going to take a lot of getting it right across a lot of different things. And the truth is, natural gas is a really good way to store energy, and we have all the infrastructure to make that happen. And so that's why a lot of people think of natural gas as a transition fuel to manage the volatility, and the seasonal storage in particular is the natural gas, and potentially eventually with I would argue pre-combustion carbon storage rather than post-combustion, but that's another story for another day.
Okay, I'm going to switch gears a little bit. Another question for Colin. We have some folks out here, I think, who are listening who maybe could test out or validate or provide some, demonstration of some flavor of the solar thermal technologies. Is there a way they can work with you to do this, or like what would you recommend for people who are interested in helping this technology come about?
Yeah, so I mean, I think the first step would be to reach out to different solar suppliers, so they would have the sort of on the ground knowledge about these systems and how they actually work in real installations. And so that would be my first suggestion. They have the experience and the know-how behind these technologies. I think from from a national lab standpoint, I think our focus so far has been on the much more on the solar side and sort of the energy production side. So we do a lot of modeling in our system advisor model. So we sort of test out and quantify technologies with that platform. We're just getting into the demand side of the equation, and so that's sort of I would say the next step in terms of looking at these technologies. But certainly to go reach out to solar suppliers, they have that know-how.
Okay, well, thanks everyone. We have a couple minutes left, and so I just want to give folks a chance to offer any last words if you have any.
I would just say maybe the important thing for me is that this eventually comes down to competitiveness of a nation, and the country or the province or whatever that finds the way to decarbonize most effectively and preserve reliability and sustainability and affordability, and all within the range of politics and physics, is going to win. And renewables are part of that, but they're only one tool in the arsenal, and you have to deploy the whole arsenal to make it work.
Yeah, I guess my closing comment would be going back to my initial slides and saying that I feel really good about what's driving our growth in renewables right now, because it's not us, it's not necessarily the state of Michigan or some government mandate. It's customers that are demanding that we bring them more renewable energy, and that's really the right place to have that come from. And so we're in a good place now, but we're going to be soon facing some pretty interesting technical challenges around storage and some of these other things that we've talked about today.
I think my last point would just be to echo the previous point about how just a whole bunch of technologies are needed in this space, and it's there's a lot of work left to be done in industry, and definitely needs our attention.
All right, I think we're out of time. Thanks to all of you for your insight, and let's continue the discussion.
Thank you.
Thanks.
Thank you.
Well, good. Welcome back, and thank you, Diana and David and Edward and Colin, for what I hope was a thought-provoking presentation. This is not simple. I think Prakash and I have both talked about how important these questions are, and we need to figure out what what range of technologies, what range of pathways do we need to implement? And we'll be talking about that over the next 3 days. Thank you, everybody. We appreciate you joining us for this session and taking a few moments to talk about the program, the Latham Scholars, and hearing more about it. And I hope you will be generous in supporting them. Thank you all for being here, and thanks to our sponsors. Our conference program begins with technical sessions at 1:15 Eastern Time. You can log in through the program conference app. And please don't forget that at 5:15 this afternoon, we will have a debrief on the day's sessions and an opportunity for networking in the virtual environment. So again, thank you for participating, and I wish you a very successful conference. Thank you.